Yeah. Coming to today's session, factors influencing solubility. What are the different factors that will influence solubility? Solubility of any solid substance can be influenced by different parameters. Different factors will influence the solubility of the solid substance in the liquid. Those factors include physical and chemical properties, physicochemical properties of the solute, which include particle size, surface area, polarity, polymorphism, crystalline and amorphous state of the substance. And next factor is temperature, pressure, pH of the solution that is provided, polarity of the solvent, dielectric constant of the solvent, association behavior of the solute, solvation of the molecules, solute molecules. These are the different factors that will influence the solubility, that will affect the solubility of the solute in the solvent. Okay, and here next we'll see one by one how the particle size will influence the solubility. If you change the particle size, if you reduce the particle size, then pivot size means if you reduce the particle size, the reduced particle size may cause increase in the surface area, increase in the effective surface area. Due to increased effective surface area, what will happen? The solvent molecules that are attacking on the surface of the solute molecules will be increases. Means solute molecule surface will be more interacted with solvent molecules. By that way, the solubility of the substance will be increased if you reduce the particle size. Next, polarity. Polarity of the solvent or the solute. If the solute is a polar solute, it will be solubilized in the solvent. Polar solvents. Okay. If it is a non-polar solute, that solute will be soluble in the non-polar solvents. Next, another factor is polymorphism. Availability of different polymorphs of the particular substance will also influence the solubility of the substance in the solvent. Okay, polymorphism, different polymorphic forms of the substance will have different solubilities in the same solvent. So, depending upon the available polymorphic form of the particular substance, will affect the solubility of the substance. And next, availability of crystalline or amorphous state of the solute. If the solute is less soluble in crystalline form, okay, if the solute is less soluble in crystalline form, it may have more solubility in amorphous state. Why? Because in the crystalline state, all the molecules, whatever the solute molecules are there, they are available in an organized manner in a crystalline state. And these molecules are present in a crystal lattice. Due to the availability of active sites for the solubility, less active sites for the solubility, the crystalline state of the particular drug material or the substance may not be soluble in the solvent that is given. But in case of amorphous state, the amorphous state of the substance will not have any organized fashion arrangement of molecules. Because of that reason, all the molecules in the amorphous state will be arranged in a disorganized manner, zigzag fashion or disorganized manner. Whenever these molecules are not available in the organized manner, all the active sites, maximum active sites for the solubility will be available for solvent. So by that way, the amorphous state containing substance will be easily solubilized in the solvent than crystalline state. Okay, this is about physicochemical properties. Next, coming to the another factor, temperature. Temperature. How the temperature will affect the solubility of the substance? Here, the temperature of the solvent that is available, the temperature may influence in a different manner. Some substances, the solubility of the given substance will increase with increased temperature. Means if you increase the temperature of the solvent or the system, the solubility of the particular substance in the solvent also increases. In some cases, if you increase the solubility of the if you increase the temperature of the system, the solubility of the particular compound also, it may not increase, it may decrease. How? Why? Because if the solubility of the substance is increasing with increase in the temperature, it indicates the total system is involving endothermic reaction. Means the solubility process of the particular substance is involving in a endothermic reaction. Okay, endothermic reaction means which reaction involves consumption of heat for completing the reaction. Okay, if the solubility process of the substance is involving endothermic means which involves consumption of heat. In such cases, the solubility of the particular substance will increase with increase in the temperature. For example, if you take glucose, if you add glucose to water, what will happen? The total system, the total solution temperature may goes down. Means the solubilization process will consume the energy from outside, and it cools the system, it cools the total system. If you increase the temperature of the system at that particular state, what will happen? The solubility of the glucose in water will increase. Okay, and in another case, if you add anhydrous calcium chloride, if you add some substances to water, what will happen? The total system will become heated. For example, some anhydrous salts of calcium, anhydrous salts of calcium. If you add this calcium salts of anhydrous salts of calcium, add to water, what will happen? The total system will become heated. Means it releases heat energy during the solubilization process. In this case, if you heat the total system, what will happen? The total solubility of the calcium, particular calcium salt in the water, will decrease with increase in the temperature. Why? Because for solubilizing the particular salt in water, it is liberating its internal energy. If you are still increasing the temperature, means what will happen? The total system temperature will increase enormously. The solubility of the particular solute in the solvent will decreases. Clear ma up to this? And next one is the degree of solubility of substance can be defined by solubility product. Okay, if you want to express the solubility, the degree of solubility can be explained. Okay, this can be explained by solubility product. It is a numerical quantity which will depend on temperature and the solvent and characteristics of the electrolytes also. Okay, and here if you want to change the solubility patterns of the, if you want to increase the solubility of the substance in the particular solvent, you can increase the solubility by using different techniques. The solubility of the substance in the solvent, especially polar solvents, the solubility of the substance in the polar solvents can be enhanced by solubilization techniques. The solubilization techniques are the technique which is used to increase or enhance the solubility of the particular substance in a solvent is known as solubilization technique. Okay, here the solubilization techniques are, there are different types of techniques are there. How can you enhance the solubility? By using different solubilization techniques. These solubilization techniques are either by physical modifications, chemical modifications, and by using some other different types of methods also. If you go for physical modification, the particle size reduction. Physical modification means physical state of the particular material can be changed, modified. Okay, here particle size reduction. First one is particle size reduction, reducing the particle size. If you reduce the particle size, the effective surface area that is available for the total solubilization process will be increased. So the solubility of the particular system will be increased. And next, second modification is modification of the crystal habitat. If you change the crystal habit, crystal lattice structure or crystal habitat, you can change the solubility of the particular substance. Next one is another modification is complexation. By complexing with the, what we can say, particular substance can be for complexed with another complexing agents like cyclodextrins. What will happen? The cyclodextrins will form complexes with the given drug molecule, and these complexes will be useful for solubilization, increased solubility of the particular substance. This is about physical modification of the substances. And next, by changing the chemical nature, chemical modification. In this chemical modification, you can change the pH of the surrounding system, or you can use another different types of buffers for increasing the solubility. Okay, and another methods used for enhancing the solubility are co-solvency, co-crystallization, hydrotrophy, by using solubilizing agents, using soluble prodrugs. These are the another techniques that can be used to enhance the solubility of the particular drug. This is about temperature. And next, coming to pressure. Generally, the solubility of the solid substances will be less affected by externally applied pressure. Generally, pressure will influence the solubility of gases in the liquids. Okay. And next, the fourth factor is pH of the solution. Just now I told, if you change the pH condition of the surrounding media, you can you can change the solubility of the particular substance. For example, if you take a weak acid, just to say aspirin, weakly acidic drugs, just to say benzoic acid or salicylic acid. This weak acid, if you add simple pH 7 containing water, simple water, which pH is 7. The solubility of benzoic acid in water, plain water, will be very less extent. But if you change the pH of the surrounding media, means if you change the pH of the water from neutral to alkaline condition, what will happen? The solubility of benzoic acid in the media will increased. Why? Because as this benzoic acid is added to the alkaline pH condition, what will happen? The benzoic acid is an acid drug, and here we are adding alkaline condition, means basic solution. What will happen? The basic solution will chemically react with the acidic media, acidic drug. By that way, it will neutralize the acidic drug slightly, and it will form a salt. Okay, because of formation of salt of the particular acidic drug, the salt formed drug will be more soluble in water when compared to the crude form of the drug. Okay, so this will influence the solubility. As we are changing the pH condition of the surrounding media, by that way, the slight modification in the chemical structure of the drug will occur. So the drug will solubilize in the solvent. Okay, that is the another factor. And next one is polarity of the substance. Polarity means if the whatever the solute molecule you are having, if it is a polar solute, you need to use Polar solvent. Why? Because polar solutes will soluble in polar solvents only. Okay, if you are using non-polar solute, you have to use non-polar solvents. Why? Because intermolecular forces will come into exist, and solute and solvent molecule interactions may come into exist for solubilization process. Next, dielectric constant. This dielectric constant is related to polarity. Polarity of the solvent will be given with respect to dielectric constant. If the dielectric constant is more, polarity will be more. So, if the dielectric constant is more for the particular solvent, if the solvent can be solubilized only the polar substances. Okay. Next, association of the solute molecules. If the solute molecules are associating together while forming the solution, what will happen? The association containing what we can say, especially this association property will be influenced by intramolecular hydrogen bonding. Intramolecular hydrogen bonding means two substances, no, sorry, not the two substances, two molecules of the one substance. They may interact together because of the intramolecular hydrogen bonding. Intramolecular hydrogen bonding means the molecule, this molecule of the one compound and this molecule of the one compound. What will happen? They will associate together. Sorry. Uh, they will associate together, and what will happen? They will form strong associates of the particular material. In such case, what will happen? These associations, these particular interaction, it may be it may reduce the solubility of the particular drug material in the solvent. How it will reduce? If the association properties are more predominant than the interacting with solvent molecules, what will happen? There will not be interaction of solvent molecules with the solute molecules. So what will happen? Thus all the solute molecules associate together and they will precipitate out from the solution, and they will not be coming into the solution form. They will be settling as solute molecules. Solute molecules are separated out and solvent molecules are separated out. So there will not be any solubility of the substance in the solvent. So for proper solubilization process, the drug molecule or the substance molecules should not associate together. There should be existence of interaction between solute and solvent molecules. If the solute molecules are interacting together, what will happen? All the solute molecules are associated together and they will precipitate out. And next, solvation. What is the meaning of solvation? Another factor is solvation. Solvation means, just take an example of, you have placed a solute substance in the solvent called water. Whenever the solute is added to solvent, what will happen? Immediately, depending upon the properties of the solute, the solvent molecules will come and attack on the solute surface. And next, what will happen? This, if the solute surface is hydrophilic in nature, for example, if it is a polar substance, if the substance is a polar substance and this polar substance is added to polar solvent, what will happen? The polar substance surface will be attacked with the polar solvent molecules. So what will happen? These polar solvent molecules, they will form a thin occlusive layer on the surface of the solute surface. So the formation of thin layer of the solvent molecules on the surface of the solute is called as solvation. Formation of a thin layer of solvent layer on the solute surface is called as solvation. And this solvent surface, solvent layer will be having association with or interaction with the direct interaction with the solute molecules. So what will happen? These solvent molecules will grab some amount of solute molecules and they will go away. Then whenever these are saturated, these are replaced with fresh amount of solvent onto the surface of the solute. The formation of solvent layer is called as solvation. Whether the solvation process is going or not, that particular step will influence the solubility of the particular drug material. Is this clear, ma, everyone? Hello?